Welcome to section 7. In this section, we are going to learn something that every programmer faces in his coding journey: errors. When you write code, mistakes will happen. A file might not exist, a number might be divided by 0, a user may enter the wrong input, a database might be unavailable. These mistakes, when they stop the program, are called exceptions. Python allows us to handle exceptions gracefully, so that instead of crashing, our program can show a friendly message, retry the operation, skip the faulty part, or log the error. Exception handling makes your programs reliable and professional. The most basic form of exception handling uses try and except. Let's see its structure. Try, code that may cause error. Except, handle the error. Example, try num equal to int input enter number, print 10 divided by num. Except, print something went wrong. If the user enters 0 or invalid input, the except block will catch the error and display the message something went wrong. It's important that we use general except only for beginners, and later we handle specific exceptions. Handling specific exceptions. Python provides many specific exceptions such as value error, zero division error, file not found error, type error, index error. Handling specific errors makes your program more accurate. For example, try num equal to int input enter a number, print 10 divided by num. Except value error, print please enter a valid number. Except zero division error, print you cannot divide by 0. Here different errors are handled differently. This is the recommended way to manage errors in real applications. The else and finally blocks. Exception handling can include two more optional blocks. Else block runs only if no exception occurred. Try file equal to open abc.txt or except file not found error, print file not found. Else, print file opened successfully. Finally block runs no matter what happens, error or no error. Try file equal to open abc.txt or except file not found error, print file not found. Finally, print execution completed. Finally is especially useful for closing files, releasing resources, closing database connections. In the above example, we see that in case file not found error occurs, file not found message is displayed, and despite if the error occurs or does not occur, the finally block is meant to run. So print execution completed will run in case the program runs successfully or in case there is a file not found error. Best practices for error handling. Here are some important guidelines. Always handle specific exceptions. Don't use broad except unless absolutely necessary. Write meaningful error messages, not just error. Tell the user what went wrong. Use finally for cleanup tasks. Always close files, database connections, etc. Don't hide errors. Let important issues surface so they can be fixed. Log errors in real-world applications. Instead of printing, save them into log files. Professional programmers use these practices daily. Sometimes you want to raise your own errors when something is wrong. Python allows you to use the raise keyword. For example, age equal to -5. If age less than 0, raise value error, age cannot be negative. Another example inside a function, def divide a comma b. If b equal to 0, raise zero division error, cannot divide by 0, return a by b. Raising your own exceptions helps enforce rules and validations in your programs. You can also create your own exceptions using classes. For example, class toSmallError exception pass. Num equal to int input enter a number. If num less than 10, raise toSmallError, number is too small. Here in this example we see that we have created a custom exception called toSmallError, which is defined as our requirement of a number more than 10. So in case we receive a number less than 10, we can raise this error and display a suitable message to the user. Custom exceptions are useful when building large applications, creating your own rules, designing clear error messages. This is advanced but very useful for professional code. Try these exercises. First, write a program that handles division by 0. Second, ask the user for a number and handle invalid inputs. Third, create a function that raises an exception if age less than 18. Fourth, handle file not found error while opening a text file. Fifth, create a custom exception called negative number error. These exercises strengthen your understanding of exceptions. Let's build a small project that uses error handling, a login system. The required features are ask for username and password, handle incorrect input, validate password length, use try except blocks. Let's have a look at the code. The program has a login function which accepts the username and password. In case the entered password is less than 6 characters, a value error is raised. The username and password are checked against valid values and a success message is displayed in case they match. Otherwise, invalid username or password message is displayed. The main program has a while true loop which displays the menu options for login or exit. The following scenarios are there. First, the user enters 1. In that case, the login function is called. Second, the user enters 2. The program ends. Third, the user enters any other number. The invalid input message is displayed. Fourth, the user enters a non-numeric value. In that case, the program causes a value error exception and the appropriate message is displayed. This project reinforces handling value error, raising exception, validating user input. Excellent work completing section 7.